Hi, I'm Colin Walls, and I'm here as usual to talk about embedded software. Today, this is the first of an occasional series of videos looking at features and functionality of real-time operating systems. Now, all RTOSs have different features and functionality, but a lot of it is quite common, and where I need an example, I'll be using our Nucleus real-time operating system. Today, I want to look at inter-task communication, specifically sending data from one task to another. Now, there's various ways this can be achieved, but we'll start off by looking at some of the basic mechanisms. Now, if you simply want to send an item of data from one task to another, what you do not do ordinarily is use a shared memory location and just pop the data in there. There are too many reasons why that is a problem in a multitasking context. Because of that, we have specific facilities built into operating systems to do the job for us. And the first of those is a mailbox. Now, a mailbox is simply a location into which you can store some data in a controlled way to pass it from one task to another. Typically, this would be a 32-bit data location, and maybe we have two tasks. One task is going to write data into the mailbox, and once it's done that, the mailbox is then considered to be in use. And if another task were to try to write to that mailbox, it would fail, or it might be suspended pending the availability of the mailbox. That's your choice. Another task can read data from it, and when it does read the data, the mailbox is then marked as available again. If a task tries to read data from an empty mailbox, again it would fail, or it can be suspended pending data arriving there. So a mailbox is a very simple way of passing 32-bit data between tasks. If you need something a little more complex, for example, perhaps you have a supply of data and a consumer of data which are not necessarily working at the same speed, so maybe data arrives in bursts and is processed at a steady rate. Well, you need some kind of buffer. And the kind of buffer we would typically use is a first in, first out buffer, which we call a queue. Now, a queue is simply like a bunch of mailboxes glued together. So the example we have here, we have 4 entries. Again, we have 2 tasks. One is going to put data in and one is going to take data out. So the first task can push some data into the queue, and then it can push some more data into the queue. And it can keep doing that until the queue is full. If the queue is full, then again it will fail or be suspended accordingly. And in the same fashion with mailboxes, the other task can read data out of the queue if there's anything there to be had, and as it reads it out, the queue capacity is suitably increased, so each item is taken off the queue. Being a first in, first out buffer, it's implemented as a ring buffer actually, but you don't need to know that. You just push data in one end and it comes out the other from your point of view. There are sometimes additional calls available to the operating system to let you do other things, one of which is called jamming, where one task passes data to another but pushes it on the front of the queue rather than the back of the queue. That's a fairly specific possibility. The complexity of inter-task communication can become much greater. It depends on the operating system, as I said, but an example of something more complex would be a thing called a pipe. A pipe is almost identical to a queue, but instead of dealing with one-word items of data, 32-bit data, it will deal with strings of bytes of some specific length. So it enables you to pass more complex data structures or text or whatever it is you need to pass between tasks. So that's a brief introduction to passing data between tasks. This is a subject which I've been covering along with lots of other aspects of real-time operating systems on embedded.com. I have a series of articles called RTOS Revealed. So if you use embedded.com, take a look. You can see what I've been writing about there. And those articles will be carrying on in the months ahead of us. In future videos, I'll be talking about other aspects of real-time operating systems and of course other topics on embedded software. So that's all for today. Look forward to seeing you next time. Bye for now.